Student, I already explained the types of colloid according to disperse phase and dispersal medium when they are solid, liquid or gas. Now I am going to explain types of colloid according to affinity of disperse phase and dispersal medium for each other. According to these, colloids are of two types: lyophilic colloids and lyophobic colloids. Lyophilic colloids and lyophobic colloids. What is lyophilic colloid? Now I explain. Lyophilic colloids are those colloids, we can say it solvent loving colloids also. In these lyophilic colloids, when disperse phase come in contact with dispersal medium, they instantly convert into colloidal state. They are solvent loving colloids. For example, gelatin or starch, when we add into water, they instantly convert into colloidal state. Now lyophobic colloid. Lyophobic colloid, we say that solvent hating colloids, those colloids which do not convert into directly into colloidal state. For example, we take metals or metals hydroxide, metal sulfides. When we add into water, they do not convert directly into colloidal state. They take time to convert into colloidal state. Okay, so we say that hydro, when we add starch into water, that time we say that hydrophilic colloids, and here metal hydroxide we add into water, hydrophobic colloids. Hydro we use for water. After types of colloids, I explain characteristics of colloids. First, nature of colloids. Colloids are heterogeneous in nature. Heterogeneous, they are not uniformly mixed. Heterogeneous in nature. Size of particles. Size of colloidal particles are in between 1 nanometer to 100 nanometer. They are not visible by our naked eyes, but they are visible under microscope. Stability. Colloidal solutions are stable. After leaving undisturbed for many hours, they do not settle down. Means they are stable. So student, colloidal solution are stable. Filtration. By the method of filtration, we cannot separate our colloidal solution, because all the particles of solute, all the particles of colloidal solution, they easily pass through the filter paper. Now, Tyndall effect. First I explain what is Tyndall effect. When beam of light pass through a colloidal solution, path of light is visible. Path of light visible, these phenomenon we say that Tyndall effect. When beam of light pass through any colloidal solution, the particle of colloidal solution are big enough to scatter the light. When they strike to the light, beam of light, they scatter the beam of light, and then the path of light is easily visible. You can see this phenomenon at home also. You take a transparent beaker or any glass, and inside that you take milk, and in dark room you keep that milk, and beam of light with a torch, you can focus on beam of light on milk, and then you see the path of light inside the milk. This effect we say Tyndall effect. Tyndall effect show colloidal solutions, so Tyndall effect, because its particles are big enough, but solution do not show Tyndall effect because its particles are very small. Now next property, Brownian motion. What is Brownian motion? When we see our colloidal particle under a microscope, you can see that particles of colloidal solution particles are continuously moving in random, and these motion we say that zigzag direction they are moving, and this motion we say Brownian movement. Next property, charge. Colloidal particles carry charge, but particles of solution do not carry charge. Particles of suspension do not carry charge. Electrophoresis. First I explain what is electrophoresis. After that I explain here. You know that colloidal particles carry charge when we conduct electricity through the colloidal solution. The charge particle deposited to the oppositely charged anode or oppositely charged terminals. You see that negatively charged particles deposited to the positively charged terminal, and positively charged particles carry deposited at the negatively charged. These process we say electrophoresis. Now coagulation and electrophoresis, colloidal solution, so electrophoresis and coagulation. When all of you know that they carry charge, when we know that any colloidal particle carry any charge, either positive charge or negative charge, due to similar charge they do not settle down at the bottom at one place. Due to the similar charge they have repulsion, and due to this repulsion they do not settle down, and to this process, to settling that, we use different electrolyte which have particles which have different charge particles, and this process we say coagulation. So student, you know that colloidal solutions are stable, they do not settle down, but to settle down their particles at one place to separate, we use oppositively charged electrolytes, and they settle down and we separate that. This process we say coagulation. Colloidal solution, so coagulation, because they carry charge. And after that, usage of colloidal solution. Colloidal solution generally we use in our food, in our medicine. For example, we are using milk, we are using jelly, jam, these things are butter. These are the examples of ice cream. It is also the example of colloidal solution. Medicine, we use many types of syrup, ointment. They are the examples of colloidal solutions. In next video I will explain separation of substances.